Welcome everyone, and thank you for joining us for this special autumn water cooler webinar, part of our quarterly Better World project series. I'm your host Parag Vasekar from the Purdue Research Foundation, and I'm honored to moderate today's conversation. I'm also the co-chair of Autumn's Better World Project Committee. These sessions are designed as informal yet insightful conversations, a space where our community can come together to reflect, to learn, and to celebrate the remarkable work happening across university tech transfer. From invention to impact, the Better World Project sits at the heart of Autumn's mission, telling stories of how academic innovations move beyond the lab and into the real world, creating meaningful, measurable change. Over the years, the Better World Project has become a powerful showcase of successful success stories that span healthcare, agriculture, material science, sustainability, and a lot more. From life-saving vaccines to clean water technologies, and from AI-powered diagnostics to biodegradable packaging, these innovations illustrate the indispensable role of tech transfer professionals, university researchers, and industry collaborators. They also highlight the critical importance of continued investment in basic research. But this is not just a celebration of past success. It's a forum for exchange of ideas, for connecting over shared challenges, and for exploring what's next in our field. So think of this as your virtual water cooler, where we spark conversations about inclusive innovation, evolving IP landscape, and real world impact of our work. Today's session takes us to the intersection of innovation and sustainability, where we'll explore the story behind PurePod 100, world's first certified 100% compostable single-serve coffee pod. This breakthrough is a result of a unique collaboration between the University of Guelph and Competitive Green Technologies, demonstrating how a vision for a greener planet can become a market-ready solution through university industry partnership. So joining us today are two key voices behind this innovation. Steve D. Brabender, Director of Technology Transfer and Industry Liaison at University of Guelph. Steve has played a pivotal role in connecting academic research with commercial opportunities, particularly in bioeconomy space. Hello, Steve.
Hi, thanks for having me.
Yeah. And Mike Tyson, President of Competitive Green Technologies, who combines both farming and engineering expertise to develop sustainable, commercially viable biocomposite resins from undervalued biomass, supporting a global bioeconomy vision. Hello, Mike.
Hi, Parag. Thank you.
So grab your coffee. Compostable pod is optional. And let's dive into this compelling story of innovation, impact, and environmental transformation. We encourage you to join in with your questions and insights. Let's explore together how academic research continues to shape better, more sustainable world. Let's begin by setting the stage. To understand how this remarkable collaboration came to life, we'll start with a broader innovation environment and how the partners found each other. So, Steve, my first question is for you. Can you give us an overview of the University of Guelph's approach to technology transfer and how it encourages collaboration with industry?
Sure. Our university and our approach to technology transfer takes, I would say, a practical and applied position most of the time. The University of Guelph, we are very strong in agriculture and veterinary science, although we're a comprehensive university. And as a result of that, over the course of the past 100 plus years, We've developed strong relationships with a lot of companies as well as producer groups and so on. And so a lot of the research is kind of close to market already. With regard to tech transfer itself, our overarching goal is research impact. That's kind of our number one goal. And so if we are able to connect a researcher or a technology with somebody who is going to commit to taking it to market, we can usually agree to something pretty quickly.
That's great, Steve. Thanks for that background. So, Mike, uh, tell us about your first encounter with this technology and what attracted you to partner with the University of Guelph.
Coming from a third generation greenhouse farming background, my initial connection with the University of Guelph was rooted in its renowned agricultural expertise. My early interactions with the university centered on advancing greenhouse growing strategies and exploring innovative field crops such as miscanthus, a purpose-grown energy crop. This established a strong foundation of trust and collaboration. When I learned about the University of Guelph's Bioproducts Discovery and Development Center, BDDC, and its pioneering work in sustainable biomaterials, I saw an opportunity to align my agricultural experience with cutting-edge bioproduct innovation. The university's leadership in agricultural and bioproduct research, combined with its commitment to real-world applications, made it an ideal partner. The BDDC's focus on developing compostable materials like the PurePod 100 resonated with my vision of creating sustainable alternatives to fossil fuel-based products, driving our partnership forward.
Yeah, that's great, Mike. When I was reading about your background, I was very intrigued to read that you have background in agriculture as well as your in the engineering expertise, and you try to combine both the skills into your projects. To taking it further, Steve, I'd like to learn your version of the story. How did this partnership with the competitive green technologies come about, and what made them an ideal licensee for this technology?
Sure. Well, this is a case where the leadership came from the bottom up. It came, well, I say bottom, real top down, really, we're the bottom. But it was led by the faculty as well as the partner, Competitive Green Technologies. The great thing about the BDDC, as Mike was saying, is that they're very focused on developing solutions, and they care when they're developing solutions. They look at what does it cost? They look at how easy is it to make? They look at what are the materials that are available, and they look at what are the properties we need to achieve in order for it to be usable. And that's always at the forefront of what they're doing. So it makes them kind of ideal to work with companies because they're asking the same questions that the companies are asking. In this case, so the BDDC started at the University of Guelph around 2009, when Dr. Mohanty and Dr. Misra joined the university from Michigan State previously, and they have built out the BDDC since then. The connection with competitive green technology was a matter of they came with a set problem. That is, they had a partner. They were able to put together the supply chain a little bit. They had an end customer that was looking for, hey, we want a compostable ring. This is the ring we're trying to replace. Can you do this? And so the project kind of developed between competitive green technologies as well as their customers, and putting the supply chain together as well and bringing all of them into a meeting with Bioproducts Development Center and kind of agreeing together, this is what we're going to try. And so as a result of that, the project came together, and BDDC was able to come up with a solution that was workable.
Fantastic. now that we have heard about how this collaboration began, let's explore the nuts and bolts of this journey from lab discovery to real world manufacturing and the product launch. So, Steve, uh, what role did your team at the Catalyst Center play in accelerating the commercialization of the compostable coffee pod?
Well, we're not actually called Catalyst Center anymore. We're the Research
Oh,
Innovation Office, but I would say that our role aligns with the name Catalyst Center at the time. Um, we're here, we exist to reduce the energy required to make a collaboration happen. And we recognize that all the ingredients in a chemical reaction have to be there, and our role is to make it easier. And so we worked with the researchers, we worked with competitive green technologies. If there's questions around intellectual property, we can address those. If there's questions around, hey, who owns what, we can address those. If there's, let's put an agreement in place, let's decide on a royalty rate, let's decide on how we're going to work together, let's decide on how the relationship's going to go forward into the future, and just removing obstacles that the research team and the commercialization partner, Competitive Green Technologies, have. And that's kind of when things work really well, our role is simply greasing the wheels or being a catalyst or basically reducing the activation energy to making these things happen.
yeah, that's right, Steve. Can't agree more with you. So, being a tech transfer professional myself, thanks for those insights. So, Mike, coming back to you, what were the key technical or business challenges that you faced in scaling this compostable ring material to industrial production?
Technical challenges. Achieving consistent material properties was a significant hurdle. The compostable ring material needed to meet stringent performance requirements, such as durability and compatibility with existing manufacturing processes. This involved optimizing the formulation to ensure the material could withstand high-speed extrusion and molding processes without compromising quality. Fine-tuning the blend of coffee chaff and other bio-based components required extensive testing to balance compostability with mechanical strength, all while ensuring the material met food-grade standards. From a business perspective, the primary challenge was competing with the established fossil fuel-based resins that dominate the market. These traditional materials benefit from the economies of scale and lower costs. So our goal was to achieve comparable extrusion production rates and molding cycle times to minimize the cost differential. This required close collaboration with customers to integrate the material into their production lines without significant retooling or downtime. Additionally, building a reliable supply chain for coffee chaff and ensuring consistent quality across batches was critical to maintaining cost effectiveness and market competitiveness. Through iterative refinements and strategic partnerships, we were able to bridge these gaps and make the compostable ring a viable alternative.
Yes, Mike. So you already mentioned about the coffee shop, and when I was reading about this story, what really intrigued me was the idea of using coffee shop as natural fiber, which is brilliant. So I'm just curious, how did this idea take shape, and what made it viable from a supply chain perspective?
The credit for the innovative use of coffee chaff as a natural fiber goes entirely to Dr. Mohanty and the team at the Bioproducts Discovery and Development Center, BDDC, at the University of Guelph. Their expertise in identifying and repurposing agricultural byproducts sparked the idea of incorporating coffee chaff, a dry, abundant waste product from coffee bean roasting, into bio-based composites. The concept took shape through the BDDC's research into sustainable materials, where coffee chaff emerged as a promising candidate due to its unique properties. From a supply chain perspective, Coffee chaff is highly viable for several reasons. First, its low moisture content is ideal for compounding biomaterials, as it reduces processing costs and challenges associated with wet or variable feedstocks. Second, coffee chaff is a scalable resource generated in large quantities by coffee roasters worldwide. In Southern Ontario, where our Leamington facility is located, numerous coffee roasters operate within a reasonable shipping distance, ensuring a steady and local supply. Third, coffee chaff originates from food-grade facilities, so it can be processed to meet food-grade standards with proper handling protocols, making it suitable for applications like the single-serve pods. Finally, as a former waste product destined for landfills, coffee chaff is cost-effective, aligning with its economical goals of sustainable production. The combination of availability, quality, and affordability made coffee chaff an ideal choice for scaling the PurePod 100 material.
Yeah, thanks, Mike, for sharing those perspectives in detail, and that's really interesting. So, Steve, coming back to you, I understand that the license deal was completed in less than a month, which is quite fast by tech transfer standards. So what factors contributed to this speed?
I think that for the most part, any of these agreements, if people are motivated to complete an agreement, then there's no reason for it to take a long time. If you think about the components of a license agreement, or at least the parts that typically are negotiated, it's things like, hey, what's the royalty rate? What's the reporting schedule? What do we do about intellectual property? And then you get into boilerplate stuff like indemnities and liabilities and so on. And when people are negotiating around liabilities, yeah, it can start to take a long time. But if you have a partner that understands the limitations that a university has with regard to liabilities and everything, and what you're really just negotiating is, okay, how much does it cost? If everybody's motivated to get to a solution, you're going to get to a solution. And so I don't see, especially if the commercial path is already kind of known, it's like, yes, we want to use this, we already know we want to use it, then doing a license agreement is frankly not that hard. And it shouldn't take a long time.
Yeah, I agree with you, Steve. Like, it sounds like there was a lot of clarity in this deal process, right from the outset. So I'm not surprised that you complete that within a month. Mike, how did you approach the trial and error process in real world manufacturing, and how long did it take to get it right?
The trial and error process for scaling the PurePod 100 material was methodical and collaborative, leveraging the expertise of the BDDC and our ISO 9001 certified quality management system. We adapted a systematic approach, starting with lab scale formulations and progressively testing them in real world manufacturing environments. The BDDC provided critical technical insights into the material composition, while our team focused on optimizing extrusion and molding parameters to achieve consistent quality and performance. Each iteration involved rigorous testing to ensure the material met industry standards for strength, compostability, and compatibility with existing production equipment. This process was not without challenges. Early formulations sometimes struggled with inconsistent flow rates, molding defects, requiring adjustments to the material blend and processing conditions. By maintaining a data-driven approach and documenting each trial, we were able to refine the material systematically. The entire process from initial concept to reliable industrial production took approximately 2 years, reflecting the complexity of aligning technical performance with commercial viability. The partnership with the BDDC and our commitment to quality assurance were instrumental in achieving the desired outcome.
Yeah, thanks, Mike. That sounds great. So, Steve, coming back to you, as Mike mentioned that this was a highly iterative technology with multiple manufacturing trials. So, how did you support the evaluation of the product beyond the lab?
So the support of developing it had very little to do with our office, and all of that credit really goes to Dr. Mohanty and Dr. Misra at BDDC. As I mentioned at the beginning, they have a strong commitment to making their products do something or go somewhere or be used by industry. And as part of that, they have a lot of fantastic equipment available to them. And so a product like this coffee chaff based compostable resin, all of the back and forth, so Competitive Green Technologies or their partners, they come back and say, this is great, but it needs a little bit more of this, or it needs a little bit more of that. They met with the researcher and Dr. Mahanti and Misra and their team were prepared to, yeah, we'll try this, we'll try that. And the iterative approach, and I do understand that this is not very replicable across a lot of different research teams, but this team in particular, um, they are more than happy to iterate 100 times if that's what it takes to get the product in a condition that it is usable by the partner. So that iterative approach is really a credit to the researchers here.
Thanks, Steve. Let's shift our focus now to what all this hard work achieved and what others can learn from this successful case of sustainable tech transfer. So, Mike, PurePod 100 has now been scaled significantly. Uh, can you quantify its environmental or market impact today?
The environmental and market impact of the PurePod 100 is substantial and growing. By diverting weekly trailer loads of coffee chaff from landfills, we've transformed a waste product into a valuable resource. Annually, approximately 300 million single-serve, single-use coffee pods made with PurePod 100 are now composted instead of ending up in landfills, significantly reducing waste and greenhouse gas emissions associated with traditional plastic disposal. This shift contributes to circular economy by replacing fossil fuel-based materials with compostable alternatives that break down naturally. From a market perspective, PurePod 100 has gained traction as a sustainable solution in the single-serve coffee industry, meeting consumer demand for eco-friendly products. Its adoption by major brands demonstrates its commercial viability and has helped position our company as a leader in bio-based materials. The success of the PurePod 100 has also paved the way for further innovations, expanding our portfolio and influence in the sustainable packaging market.
Yeah, fantastic. It's great to hear the impact of that scale. So, Steve, what lessons from the PurePod's success would you share with other tech transfer professionals seeking a similar impact?
I would say in terms of the lessons, it's probably repeating myself a little bit and things that many of the people who watch this will kind of know intuitively. And it is to be that catalyst, if you will. You know, our role is research impact, less so than get the last dollar, less so than um, make life difficult, if you will. And I think most of us, our goal is not to make lives difficult. So that's working with the research team, working with the partner, and making ways for them to be successful. Because if we end up in a scenario where the university administrative staff, the tech transfer office is a barrier instead of a facilitator, then those are the cases where something has gone wrong. And so I would encourage people to always think about how is this going to have impact and how am I going to facilitate something, um, and worry a little bit less about some of the details that aren't some red flag, red line. We can't possibly agree to this because it's an unacceptable risk to the university. Yes, put that aside. But in terms of that more commercial terms, I would just say, you know, to be collaborative and facilitative where possible.
Yeah, thanks too for sharing those valuable insights. So, Mike, coming back to you, as an entrepreneur working with the academic partners, what advice do you have for others looking to bring sustainable university technologies to market?
Great question. My advice to entrepreneurs seeking to commercialize sustainable university technologies is simple but critical. Never give up. The journey from lab to market is fraught with technical, financial, and regulatory challenges, but perseverance is key. Build strong relationships with academic partners by fostering open communication, mutual respect. Understand the technology deeply, but also focus on its practical application, how it solves real-world problems and meets market needs. Surround yourself with a team that shares your vision and is willing to iterate relentlessly. Finally, protect your intellectual property early and ensure alignment with your academic partners on commercialization goals. Success comes from combining passion with patience and a commitment to seeing the process through.
Thanks, Mike. So finally, let's zoom out and reflect on the partnership dynamics and what the future holds. What can the others take away from this collaboration, and more importantly, what's next? So this question is for both of you. So what made this collaboration between university and industry particularly successful compared to other projects that you have seen? Maybe Steve, you want to go first?
Um, I think probably the biggest factor that made this successful is the relationship between competitive green technologies and the BDDC. CG Tech meets with the BDDC more often than I do. BDDC meets with CG Tech very, very frequently. There's lots of questions, and it's not just this technology, the PurePod 100. This is one technology, and if this was the only thing happening between BDDC and competitive green technologies, then maybe there would be less cause to communicate regularly. But there are, as Mike alluded to previously, you know, this has kind of built an opportunity and a basis upon which they can pursue other opportunities in the food packaging space, sustainable packaging space, and they have done so. And so that willingness to spend the time on the collaboration, I think, has made that collaboration very successful. And this partnership between BDDC and Competitive Green Technologies has won awards. It's been recognized in a Governor General's Award, by an NSERC award, just because it is a great example of a publicly supported high-tech facility with focus on industry needs, working with a company that is willing to take the time to understand the people at the facility and the facility itself and find a way to collaborate that kind of lifts both sides up. And so I give a lot of credit, of course, to our research team at BDDC, but I also give a lot of credit to Competitive Green Technologies to kind of travel the ups and downs inherent to any relationship like that.
That's great. Mike, do you have any additional comments?
Yeah, I would say the success of our collaboration with the University of Guelph's BDDC stems from three core elements: total unwavering commitment, perseverance, and trust. Of course, underpinned by robust protection of intellectual property. Both parties were fully invested in the shared goal of creating a commercially viable, sustainable product, taking innovation to market. The university brought cutting-edge research and technical expertise, while our industry perspective ensured the technology was tailored for real-world applications. This alignment was reinforced by mutual trust, allowing us to navigate challenges openly and collaboratively. Protecting intellectual property from the outset provided a clear framework for innovation, ensuring both sides could focus on development with clarity. Compared to other projects, this partnership stood out for its shared accountability and relentless drive to overcome obstacles together.
That's great. So, Mike, you already mentioned the keys to success are perseverance, commitment, and trust. So, how important was trust and flexibility in navigating the R&D to commercialization journey?
So trust and flexibility were the foundation of our R&D to commercialization journey, akin to paying the green fees to even play the game. Trust between our team and the University of Guelph's BDDC enabled open communication, allowing us to share challenges, insights, and feedback without hesitation. This was critical when navigating the uncertainties of developing new material, as it fostered a problem-solving mindset. Flexibility was equally vital, as scaling a bio-based material required adapting to unexpected technical hurdles, supply chain constraints, and market demands. By maintaining a collaborative and adaptive approach, we were able to pivot when needed, refine our processes, and ultimately bring the PurePod to market successfully.
Yeah, that sounds fantastic. Steve, do you have any additional comments?
No, I think Mike covered it off, and I feel like I'd be repeating myself if I added more. So I'm happy to answer any other questions.
Okay. Okay. So, what are you working on now that builds on the momentum of the PurePod 100 project?
So building on the success of the PurePod 100, we are expanding our portfolio of compostable products to address a wider range of single-use applications. Current projects include compostable single-use utensils, condiment packs, K-cups, yogurt cups, espresso pods, food trays, and lidding and film. These initiatives leverage the same principles of sustainability and innovation that drove the PurePod 100, utilizing coffee chaff and other bio-based materials to create high-performance, eco-friendly alternatives to traditional fossil plastics. By collaborating with the BDDC and other partners, we're continuing to refine these products to meet industry standards and consumer expectations, further reducing waste and advancing the circular economy.
That sounds great. Thank you very much, Steve and Mike. So that was a final question from my side. I think the forum is now open for questions from the audience. So please type in your questions in the chat box. So do you have any questions already?
We do not yet.
Okay, yeah. So anyone has questions, please feel free to type.
We did a very good job of explaining.
Yeah. Okay. Yeah. So thank you again, Stu and Mike, for sharing such rich insights into the innovation journey behind the PurePod 100. So this is exactly the kind of story that underscores the value of strong university industry partnerships, visionary research, and bold entrepreneurship. For those of us working in tech transfer, sustainability, or innovation, this conversation reminds us of what's possible when we really think beyond the lab bench and embrace collaboration at every possible step. Uh, Thank you, everyone who joined us today. Thank you again, Stu and Mike.
We do have one question
Okay.
from David Hobson. What would you do differently the next time?
I think from my side, thinking back, we were so involved in the commercialization of this product. It really was all encompassing. But, to do it again, I would make sure we put enough time and effort into other products to make sure that, in tandem, in parallel, that we were, looking at the next opportunity and the next products. It just takes a long time for development, and they need to be done in conjunction with commercialization.
That's great. Do you have any other questions, Megan?
No, we do not have any other questions.
That's great. Thank you again, Stu and Mike. Thanks, Megan, for your help in setting this up. So stay tuned for future autumn water cooler webinars as we continue to spotlight innovations that are making world a better space. Thank you.
Thank you very much.
Thank you.